Hey, this is Juan from OpenFord, and in this video we will do a deep dive on OpenSigner. OpenSigner is an open source self-hostable key management system that leverages threshold cryptography to provide non-custodial key issuance. It solves the fundamental challenge of digital asset security, eliminating the single point failure associated with private keys. Unlike traditional custodial solutions where third party holds the key, or self-custody, where the user bears the full burden of protection, OpenSigner utilizes a 2 of 3 threshold signature scheme. The private key is never stored in a single location. Instead, it is split into 3 shares using Shamir secret sharing. This architecture allows for a distributed trust model. By requiring 2 out of the 3 shares to reconstruct the key, we ensure that neither the user's device nor the server can unilaterally compromise the asset. This deep dive will explore the architectural components, the cryptographic primitives, and the security guarantees that make OpenSigner a robust solution for modern fintech and crypto applications. At the heart of OpenSigner is a concept called threshold cryptography. Instead of storing a private key in one dangerous place, we split it into 3 separate shares using Shamir secret sharing. Here's the magic number, 2. We only need any 2 of these 3 shares to reconstruct the full private key and sign a transaction. This is a 2 of 3 setup. Now let's take a look where the shares live. The share number 1 is the device share. It lives securely inside the user's browser or mobile device. The share number 2 is the hot storage. It's stored in a hot storage server that you, the developer, can host, and it's accessible frequently for daily operations. Number 3 is the cold share. This is your safety net. It lives in a separate cold storage server, often called Shield, and it's only used for recovery when a user loses their device. For everyday use, like logging in or signing in a transaction, the user's device combines its local share with hot storage. They reconstruct the key, sign the data, and this is the crucial part, immediately discard the reconstructed key. The full key never persists on disk. It exists only for a split second in memory. Security in OpenSigner is built on a defense in depth strategy. Let's break down the critical security layers, starting with the execution environment. The iframe sandbox. All key reconstruction and signing operations occur within an isolated iframe. This provides a hard boundary between your application logic and the sensitive cryptographic operation. Even if the parent application is compromised via XSS, the attacker cannot access the memory space of the iframe, where the key briefly exists. How can you trust that the code running in that iframe is good? We use cosign. For container signing, every build is signed by our CI/CD pipeline in GitHub Actions. You can cryptographically verify that the image you are running matches the source code exactly and hasn't been tampered with. Furthermore, the iframe asset includes derived checksums. The hash of every JavaScript file is generated at build and time. The client can verify these checksums before executing, ensuring that the static assets served has not been modified in transit or at rest. The system relies on 4 primary roots of trust. 1. The authentication service. It must be trusted to issue valid tokens only to legitimate users. 2. The application logic. The iframe and storage code must be corrected and free of backdoors, guaranteed by open source and attestation. 3 is the environment, the server, the hot and cold storage that runs and prevents memory scrubbing. And 4, the transport. It's strictly TLS HTTPS, mandatory to prevent actually man-in-the-middle attacks. Your threat model depends on your deployment scenario. In a fully self-hosted setup, the scenario number 1, you control components, but you also bear the risk of insider attacks. In a fully managed setup, a scenario 6, you trust a third party, like OpenFord, but benefit from their security infrastructure. The architecture allows you to mix and match, for example, self-hosting the cold storage while using a managed cold storage to distribute, trust, and eliminate single points of failure. Alright, let's take a look now at the recovery flows and what happens when things go wrong. What happens when a user drops their phone in a lake? Well, they've lost their device share. Now they only have the hot share left. That's a 1 out of 3. They need 2. This is where the cold storage comes in, but we can't just give it to anyone. So we have 3 ways to protect it. Number 1 is password recovery. The cold storage is encrypted with a key derived from the user's password. The server stores encrypted share, but only the user knows the password to unlock it. It's secure, but the user must remember that password. Number 2 is using automatic recovery. Here the encryption share is handled by the server. It's easier for the user because there's no need to remember any password, but it requires more trust on the hosting provider. To mitigate this, you can use something like 2FA, like an email OTP, to authorize the recovery. And number 3, passkey recovery. This is the gold standard. We use the PRF extension of modern passkeys to revive an encryption key. The user just scans their face and fingerprints. It's phishing resistant, seamless, and the server never sees the encryption key. It's the best of both worlds. Great, so now comes the end of the video. We've seen how OpenSigner is designed to be flexible. You can go fully self-hostable, you run the auth, the hot storage, the cold storage, and you have full control and total responsibility. Or you can choose hybrid models. Maybe you host the hot storage for speed, but you let the trusted third party, like OpenFort, manage cold storage and auth. This distributes the trust. No single entity has enough shares to reconstruct the user's key without their consent, etc. Getting started is as simple as spinning up the Docker containers. We provide you sample implementations for the hot storage and production-ready images for the cold storage. The iframe SDK drops right into the React or vanilla JavaScript applications. So hey, that's it. OpenSigner isn't just a tool, it's a new standard for user sovereignty. It allows you to build apps where users own their assets without the fear of losing them. Check out the documentation on opensigner.dev, join our GitHub, and start building the future of non-custodial applications today. See you later.